Today, we're plugging into the central nervous system of a truly massive industrial machine. We're going inside the control room of a giant mine to figure out how a single person pilots an operation that spans miles and literally moves mountains of Earth, all from one chair. Let's dive in.
I mean, really think about that question. It sounds like something straight out of science fiction, right? But for a modern mine, it's just daily life. And this isn't just about a few big trucks. It is a sprawling, interconnected factory with thousands upon thousands of moving parts. So, how in the world do you keep it all from grinding to a halt? Or worse, descending into total chaos?
Well, you give it a brain. And in this case, that brain is a human, the control room operator, or CRO. This quote from their training manual pretty much says it all. This one person sits there analyzing this constant flood of information and making these critical decisions to keep the entire plant running smoothly, efficiently, and most importantly, safely. So let's take a virtual tour of their office, shall we? We're going to step inside the plant's nerve center to see exactly what it is and what really goes on inside those walls.
The manual officially defines the control room as this single central command post. And really, it all boils down to three key things. You've got the hardware, the computers, the servers, the screens. You've got the software, that's the magic window into the plant. And of course you have the personnel, the all-important human operator we just talked about.
And the software that makes all this possible is called a SCADA system. Now that stands for Supervisory Control and Data Acquisition. But you can just think of it as the plant's digital nervous system. It's this incredible network that is constantly acquiring data from thousands of sensors out in the field, and it allows the operator to have supervisory control over every piece of equipment, translating it all into a language they can actually understand.
Okay, this is where it gets really cool. I mean, how do you take a colossal physical plant and shrink it down to fit on just a few computer screens? Let's take a look at how these operators decode this digital world.
So what you're looking at here is basically a digital twin of the entire mine. Every single pump, every conveyor belt, every giant crusher, it's all represented right here as a graphic. But this isn't just some static diagram. It's a live, dynamic map of everything happening in the plant right this very second.
Now, to keep track of literally thousands of pieces of equipment, the whole system relies on a kind of universal language. Just like every house on your street has a unique address, every single component in this plant has its own identification number. You could say it's the grammar that holds this entire digital world together.
And this shows you just how brilliant it is. Let's break down an address, like 311 CR 1001. 311 tells you the location. You're in the primary crushing area. CR tells you what you're looking at. It's a crusher. And 1001 is its unique serial number. It's simple, it's logical, and it makes any single piece of equipment instantly identifiable among thousands of others. But you know, communication is a two-way street. It's not just about the operator seeing the plant. The plant also has to be able to talk back, especially when things are not going right. So let's look at how the machine actually communicates.
So the plant really speaks in two main ways: alarms and warnings. An alarm, that flashing red A, is basically a scream for help. It means something's wrong right now, and it needs your immediate attention. A warning, on the other hand, the flashing yellow W, that's more like a cuff. It's a little heads up that something might go wrong soon, so you'd better keep an eye on it. The system also uses a really simple but incredibly powerful color philosophy. Green means everything's normal, everything's running. It's the color of a healthy, productive plant. Red, however, signals an abnormal state. Something has stopped when it shouldn't have, or it's faulted. Trust me, for an operator, a screen full of green is a very good day. All right, so the operator can see the plant. They can hear its alarms. But how do they actually do something about it? How do they go from just monitoring to actively controlling this whole thing?
So the main screen is packed with these little summaries. They're called block icons. Each one represents a piece of equipment, like the pump you see here. It gives the operator the most critical info, like is it on or off, at a single glance. Think of it as the high-level dashboard view. But what happens if you need to know more? Well, with just one click on that little block icon, the operator opens this, the faceplate. You can think of it like popping the hood on your car. This is the detailed control panel for that one specific device, where you can actually start it, stop it, and fine-tune its settings.
Now, once they're in there, they have to make a crucial choice: manual or automatic mode. In manual mode, the operator is the pilot. They are directly pushing the start and stop buttons.
But in automatic mode, the system itself takes over. It's kind of like the mine's thermostat. For example, a pump will automatically kick on when a tank gets too full. No human intervention required.
Okay, managing all of this complexity is one thing, but the real weight of this job, the true gravity of it, goes way beyond just efficiency and production. We're now getting to the operator's ultimate responsibility, the part of the job where every single click has the potential for profound, life-altering consequences.
8.
That's the number of identified fatal dangers on this mine site, and the control room operator has direct control over every single one of them. And these aren't minor issues we're talking about. These are specific, recognized risks with literal life-or-death consequences.
And these are not abstract concepts. We are talking about preventing a massive tank from overflowing, which could unleash a catastrophic toxic flood. We're talking about coordinating giant pieces of mobile equipment to make sure they don't collide, or making absolutely sure a high-voltage system is shut down before a maintenance worker gets near it, because one single mistake could be instantly fatal. Every decision carries just an immense weight.
Which is exactly why this principle, stated right there in the manual, is the foundation for everything the operator does. It is the one rule that governs every single click they make. Safety isn't just the priority here, it is the priority. It's the unwavering constant in a sea of ever-changing variables.
So it really leaves us with this one final thought. In an operation this automated, this complex, the line between the machine's job and the human's responsibilities gets, well, it gets fascinatingly blurry. The system can handle all the routine stuff, sure, but it's the operator, that human brain in the chair, who has to exercise judgment, who has to anticipate the unexpected, and who, at the end of the day, has to bear the psychological weight of holding lives in their hands.